Hey everybody, we're here doing some calculus, and this is a problem which is about not only a trapezoidal approximation, but also an accumulation of a rate. So we're going to go ahead and start with this. This is modeled on one of the problems in the textbook. And if you're using the calculus, analytical, algebraic, and graphical, I think I got that in the wrong order, but if you're using that book, this is in chapter 8.1, section called Accumulation and Net Change. This section assumes that you understand how to do a trapezoidal approximation, but we'll go over that also as we work on this. So a popular hot dog stand opens at noon. At different times between noon and 2 p.m., the manager stops to check how fast the hot dogs are selling, with the results given in the table. Use a trapezoidal approximation to estimate the total number of hot dogs sold in the first 2 hours. So the first thing we see is this table, and this table gives different values of time and rates that the hot dog sales at those moments in time. We notice also the units here of time are minutes, and the units of the rate is hot dogs per minute. Furthermore, the unit for time, minutes, matches the per minute part for the rate of hot dog sales. So if I was to integrate the rate of hot dog sales with respect to time, my response should be in hot dogs. To put that more bluntly, the integral from a to b of hot dogs per minute with respect to minute is going to be equal to the number of hot dogs from t equals a to t equals b, which is basically what we're looking for. How many hot dogs were sold from t equals a to t equals b? In our case, we're going from t equals 0 to t equals 120, and we're integrating r of t dt from 0 to 120. One thought might be to graph everything that you see in the chart, and here we've graphed everything in Desmos, and we can manually draw in all of the trapezoids that we would see. That would look something like this if we drew in all of those trapezoids. You're also going to notice that these trapezoids all have, well, most of them have different widths. So this first trapezoid over here, this looks like this is going from 0 to 10, and then this second trapezoid is going from 10 to, I don't know how much that's 35, I think. So since these have unequal widths, we cannot use the trapezoidal formula. So rather than using the trapezoidal formula, I think it's a good idea to reorganize the data into a chart that takes the width of each trapezoid into account. Here you see me beginning the chart, and I always start the chart off by putting in all of the intervals for each trapezoid. For example, this first trapezoid goes from 0 to 10, and then this second trapezoid goes from 10 to 35. And we can go on for all of the trapezoids. The second row of this chart is going to be the width. So we can actually do this without even looking at the graph. We can just see the first one, width is from 0 to 10, and that has a width of 10. The second one is 10 to 35, and that has a width of 25. 35 to 50, that's 15. 50 to 60, that is 10. 15, 15, 10, 10, and 10. So we create all of the widths for each one of our trapezoids. Now the next line of this chart is going to be a little bit different. It's going to be the average of the two heights. And to find those average heights, we're just going to go back to the first table that we have here, and we're going to find the average of, well, the first interval is from 0 to 10, and so I need to find the average of 2 and 5, and that's going to be 3.5. moving back down to my chart, we're going to put a 3.5 here. And we're going to proceed along the same pathway for each one of the intervals. That next interval is from 10 to 35, so I need to find the average of 5 and 18. That's 11.5. And then we'll go on to the next one. The average of 18 and 18 is 18. So we put an 18 in the chart until we have all the heights in our table. The next thing you're writing is an expression of the integral, and the integral here is the integral from 0 to 120 of RT. Notice how 0 and 120 match with our table and our chart. The next thing I would recommend you write is something that's a little bit symbolic, and it's the trapezoidal sum. And what this says is we're going to take half of RA plus RB. That's going to be the t on the left and the t on the right of each interval. Maybe that's better written as TL and TR. And that's the average height that we found in line 3 of our table. And then we're going to multiply that by our delta t, which is line 2 of our table. And since we already found the average height, we just need to treat this like we would if we were doing this same table for a left rectangle or a right rectangle. So we multiply 10 times 3.5 plus 25 times 11.5 plus 10 times 17, and then right on down the chart. And then at this point, it's just grabbing your calculator and multiplying that all together. And that gets us 1,582.5. I always recommend that you write a summary statement at the end here. So about 1,582.5 hot dogs were sold during those first 2 hours. You might be told to round to the nearest hot dog, but you'll have to read those rules as they come along. And that kind of concludes this problem. Pretty easy, just the idea of the accumulation of the rate and then the execution of the trapezoidal approximation. We'll see you next time.